This is a video from section 12.3 based off the lecture notes. The direction angles of a non-zero vector A are the angles alpha, beta, and gamma in the interval 0 to pi that A makes with the positive x-axis, y-axis, and z-axis, respectively. The cosine of these direction angles, cosine alpha, cosine of beta, and cosine of gamma, are called the direction cosines of the vector A. And so we have a figure here where I drew out A, and if you notice it, the initial point of the vector A is at the origin, and the terminal point of the vector A is at the corner of the box. Alpha is the angle that A makes with the positive x-axis. Beta is the angle that A makes with the positive y-axis, and gamma is the angle that A makes with the positive z-axis. Let A equal the vector A1, A2, and A3. Now, what I want to do is I want to choose a vector along the positive x-axis, and a convenient choice would just simply be I, which is equal to the vector 1, 0, 0. And then from here, I want to choose a vector along the y-axis, the positive y-axis, in fact. And so a convenient choice there would be j equal the vector 0, 1, 0. And then similarly, I want to choose a vector along the positive z-axis. And so there I chose k equal to the vector 0, 0, 1. Now, by choosing I, j, and k, that allows me to find cosine of the angle between the vector A and the vector I. And in fact, that allows me to find alpha, beta, and gamma accordingly. So if you notice, cosine of alpha is A dotted with I divided by the magnitude of A times the magnitude of I. But the magnitude of I is 1. And then A dot I is A sub 1. You're just going to get the first component. So cosine of alpha is A1 divided by the magnitude of A. And so I do the same thing for cosine of beta. Cosine of beta is A dot j divided by the magnitude of A times the magnitude of j. But the magnitude of j is 1. And so cosine of beta is A sub 2, so you're going to get the second component divided by the magnitude of A. Okay, and then cosine of gamma is A dotted with k divided by the magnitude of A times the magnitude of k. But the magnitude of k is 1. And so cosine of gamma is A sub 3 divided by the magnitude of A. Now, what I'm going to do is I'm going to look at cosine squared alpha plus cosine squared beta plus cosine squared gamma. But that's A1 squared divided by the magnitude of A squared plus A2 squared divided by the magnitude of A squared plus A3 squared divided by the magnitude of A squared. Now notice how we have the same denominator for each of the fractions. So on the second line, I wrote A1 squared plus A2 squared plus A3 squared divided by the magnitude of A squared. But we've already shown that A1 squared plus A2 squared plus A3 squared is the magnitude of A squared. So on the last line, or the second to last line, I get the magnitude of A squared divided by the magnitude of A squared. And if you notice, that's equal to 1. And so that says cosine squared alpha plus cosine squared beta plus cosine squared gamma is 1. That's how you prove that. Now, I do want to point out that I could have chosen any vector along the positive x-axis, positive y-axis, and positive z-axis accordingly to get a handle on alpha, beta, and gamma. And I claim that my cosine of alpha and cosine of beta and cosine of gamma would have been the same. So remember, I just needed a vector along those positive axes to get a handle on those angles, those direction angles. Okay, let's take a look at example 1. Example 1 says to find the direction cosines and direction angles of a given vector. So we're going to apply what we just learned. And the vector is a equals 1/2, 1, 1. So the magnitude of a is equal to 3/2. That allows me to get cosine of alpha and cosine of beta and cosine of gamma immediately. Now, cosine of alpha, I take the first component, which is 1/2, and I divide it by the magnitude of a, which is 3/2. And if I simplify, that's equal to 1/3. Cosine of beta and cosine of gamma are both 2/3, right? Because remember, I'm taking 1 and dividing it by 3/2. But when you divide by a fraction, you multiply by the reciprocal, right? You take the numerator, multiply by the reciprocal of the denominator. So again, cosine of beta equals cosine of gamma equals 2/3. And that allows me to solve for alpha, beta, and gamma immediately. So alpha is the inverse cosine of 1/3, beta is the inverse cosine of 2/3, and gamma is the inverse cosine of 2/3. And I'll leave it to you all to put that in the calculator to get the angle in degrees. And with that, let's take a look at the second example here. It says find the angle between a diagonal of a cube and one of its edges. And for argument's sake, we're going to look at a unit cube. And I put the corner of the cube, if you notice, at the origin, and the diagonal will connect the origin, that's the initial point, to the terminal point, which is to the other side of here. And that terminal point is given by 1, 1, 1. And what I want to do is I want to find the angle between that vector, which is 1, 1, 1, and this edge. And I'm just going to go for the edge along the x-axis. Could I have chosen a different edge? Yes. But I claim you're going to get the same answer regardless of which edge you choose. So I said, let alpha be the angle between the vector v and I. Remember that I, don't forget, this is the vector 1, 0, 0. And so the terminal point of this vector that I'm highlighting in black is 1, 0, 0. Now, cosine of alpha is equal to 1 over the square root of 3, right? So, in other words, I take the first component of v, which is 1, and I divide it by the magnitude of v, which is the square root of 3. And so alpha is the inverse cosine of 1 divided by the square root of 3, which is approximately 54.7 degrees. And so, again, I could have let beta be the angle between v and j, and I claim cosine of beta is 1 over the square root of 3, and beta also would be approximately 54.7 degrees. So it didn't matter which edge you chose, you would get the same answer. And that'll conclude this video for section 12.3. This is part 3. And thank you.